Attention, attention. This is an emergency message. Yellowstone National Park employees and guests, residents of the surrounding area. This is an official emergency message from the Federal Center. Please listen carefully and follow all the instructions. We have received trustworthy information about the real threat of an eruption in Yellowstone National Park. Your safety is our top priority, so we are taking immediate measures. Please stay calm and alert as we work together to ensure your safety. We are working on evacuation arrangements and setting up emergency shelters for those who need them. Evacuation routes and safety instructions are coming soon. Please refrain from spreading unverified information and only rely on official sources. We are aware of the challenges and difficulties you may encounter and would like to assure you that we are working diligently to resolve them. We would like to emphasize the importance of standing with each other at this time. Please look out for your neighbors, especially the elderly people and people with reduced mobility. Working together as a community, we can overcome this crisis. Stay strong, stay informed, stay alert. Only together will we get through this.
This is roughly how people will first learn that this time it's happening, for sure. It's been so often that the media has frightened us with the Yellowstone eruption. The end of the world has been scheduled or postponed for so many times, but it's going to happen, sooner or later. At a depth of 9.5 kilometers under the most famous national park in the world, a fiery monster slumbers, which in case of explosion will kill millions of people and change our planet unrecognizably. In this video, you will learn, what do we know today about the Yellowstone supervolcano? Could it really destroy mankind? What terrible disease struck the animals that survived the last eruption? And would it threaten us in the future? Is it possible to prevent the eruption? How much time do we have left? And is there any time at all? Dormant horror of Yellowstone. There are about 1,350 active volcanoes on the mainland of our planet, of which about 500 have erupted in observable time throughout history. Nearly 10,000 more volcanoes lie underwater at the bottom of the oceans. In 2021, researchers and ordinary enthusiasts noticed a strange and potentially dangerous trend. One by one, volcanoes began to wake up in different parts of the planet. In March, Fagradalsfjall volcano in Iceland erupted. In May, Nyiragongo in Africa erupted. In June, Rincón de la Vieja in northwestern Costa Rica. Dozens of homes were destroyed by Cumbre Vieja volcano on La Palma in Spain. Then, Fuego volcano in Guatemala also erupted. And then there was the most powerful volcano eruption of the 21st century. Hunga Tonga Ha'apai volcano in Polynesia threw out a column of ash, which rose to a height of tens of kilometers in just 30 minutes. The volcano also ejected huge amounts of water vapor into the atmosphere. The eruption continued until January 15, 2022, and caused tsunamis in New Zealand, the United States, Chile, and Peru. And that was just the beginning. The year 2022 added to the concerns of already disturbed observers. At the end of 2022, 50 major volcanoes became abnormally active. They woke up almost simultaneously. Such activity was even called Earth fever. The latest large eruption happened just yesterday. Shivalukh volcano, in one of the largest volcanoes in Kamchatka, Russia, woke up early in the morning on April 11, 2023. Pessimistic individuals regard these events in their gloomy predictions as just a warm-up before the main show. and the climax, in their opinion, should be the very eruption of Yellowstone. But did Yellowstone itself show any signs of activation? Well, the point is, yes, it did. But it has been going on for quite some time. Back in the spring of 2003, alarming events began to occur in the most famous national park in the United States. The world's largest geyser, dormant for more than 50 years, suddenly began shooting colossal jets of hot water and overheated steam into the air again. New fractures in the ground were discovered in the area. This drew the attention of national park specialists. Sometime later, 5 bison were found dead after inhaling poisonous vapors that had seeped through the ground. Satellite images showed that serious changes were taking place in the Earth's depth. Rumors were spreading over the internet, stating that a gigantic volcano, which awakens every 700,000 years, was about to erupt. Since then, a whole generation was born and grew up. And all these 20 years, the media regularly burst out loud headlines about the awakening supervolcano. If there has not been an eruption during this time, it only shows that we have less time left, because the volcano will surely erupt, right? But how do we know all this? And why did we only start to worry in the 2000s? It's actually a little more complicated than that.
If it erupts in a maximum eruption called Category 8, it could literally tear the guts out of the United States of America.
Scientists have been researching Yellowstone for years, trying to look into its past. It is in the past that researchers are trying to find hints about what the future of the supervolcano might be. And anyway, why is it actually called a supervolcano? How did people even learn that there was some sort of volcano there, plus a huge one? To find out, let's go back in time to the first half of the 20th century. Yellowstone has long been known for its hot springs. Any educated person understands that geysers are heated by something very hot at great depths, which means there must be volcanic magma very close to it. In other words, the volcano is literally right here. But there are many places with geysers on the planet, including those without any volcanoes at all. What makes Yellowstone so special? It's simple. There are 300 to 500 geysers concentrated here. That's half of all the geysers on the planet. And that's not to mention thousands of hot springs. And that means something. However, for quite a long time, the cause of such high temperatures was thought to be the residual activity of the volcano, extinct before the last ice age. Yet, on August 17, 1959, an earthquake occurred, which disproved this belief. The earthquake caused a giant landslide at Hebgen Lake in the west of the park. 80 million tons of rock fell from the mountainside onto a tourist camp. 28 tourists died. The bodies of 19 of them were never found. It was the biggest earthquake to hit the United States since 1933. As a result, it even formed a lake, which was called Quake Lake. That's when Yellowstone became the center of scientific research. Throughout the national park, geologists installed seismometers. Quite soon, it was found that up to 25 earthquakes a week occur here on average. That is, it turned out to be the most earthquake-prone area in the United States, except for California. And at that time, no one understood why. The U.S. Geological Survey thoroughly investigated the area. Now deceased, Bob Christensen was appointed as the head of the study. He would later be called the granddaddy of American volcano scientists. It was Christensen's research that informed people of the threat lurking literally under their feet. Bob and his colleagues quickly realized that Yellowstone had been a major eruption zone in the past. The soil there consisted of volcanic ash and slag. The eruption debris amounts to about 1,000 cubic kilometers of mineral rock. This is a truly tremendous volume of solidified volcanic ash, enough to fill up an entire country like India. or a third of the United States. But seeing such clear material evidence of the past catastrophe, scientists could not understand where its culprit was. Giant volumes of volcanic rock are there, but there is no volcano. What a mystery! But with over 5 years of work, Bob Christensen mapped the entire landscape of the area. Thus, as a result, he found not a cone-shaped volcano, but something resembling a giant crater, clearly visible only from the air. It turned out that the scientists, unaware of it, were literally walking on the very crater of the volcano all those years in search of it. But how did it form at a depth of several kilometers? And why is it distinctly different from other volcanoes? The fact is that under each volcano, there is a magma pocket with a narrow opening to the top, which explains the cone-like shape of any volcano. This is evident when you look at any ordinary volcano and the Yellowstone volcano in a cross-section. This is an ordinary volcano. Here we see the magma chamber at the very bottom. From here, the molten lava moves up through the vent of the volcano and erupts from above, forming a crater. Everything seems quite clear and obvious. Now look at the cross-section of the Yellowstone volcano. Any caldera-forming supervolcano would look similar. We see a slightly different picture, but overall, there are many similarities. Magma chamber at the bottom, crater at the top, except that the cone is very shallow. This is natural because of the huge area. The usual shaped cone with such a large base would have to be at least 30 kilometers high, but such a high cone-shaped mountain cannot exist on our planet. The gravity is too high. Such a mountain will be squashed by gravity in all directions, long before it can be formed. Such giant volcanoes can have a pocket up to tens of kilometers in diameter, whereas in ordinary volcanoes, it is an order of magnitude smaller. When the pressure becomes too great, the magma bursts out, and the free space is filled with the settling rock mass from above. This is how a volcanic caldera is formed. At Yellowstone, the caldera was truly enormous. It spanned across the entire center of the park. The park was literally located right above the caldera. Even then, scientists began to realize more and more how underestimated this place was in terms of potential hazards. And that was just the beginning of the research. Further discoveries only exacerbated the situation. Analysis of the ash composition led Christensen to the discovery of 2 more giant calderas in the area. Each was about 25 kilometers long and 48 kilometers wide. The eruption that produced them was 2,500 times more powerful than that of Mount St. Helens. Scientists have carefully studied the area and concluded that there were differences in the origins of the 2 formations. The geological history of Yellowstone turned out to be much longer and more dramatic than it had been previously assumed. It was discovered that the supervolcano had erupted before, and more than once, and there was no objective reason why it would not happen again. Such an eerie prospect forced the scientific community and the state to show much more attention to Yellowstone. Research expeditions have worked there almost constantly ever since. Everyone was concerned with the main questions. Was Yellowstone dangerous? Could there be an eruption? And when? And what would be the consequences? Many scientists had visited the area over the decades, and collected evidence suggested quite plainly that yes, there was a danger. Those explorers who first visited the park in the 1950s were surprised to see dramatic changes in the landscape when they returned 30 or more years later. For example, the roots of trees that used to grow on the dry lakeshore were now underwater. This phenomenon affected only the southern end of the lake. Scientists put forward an unusual theory. They suggested that the northern part of the lake had risen and the water had gone south. To check their assumptions, new surveys of the area, which had not been conducted there since the 1920s, were made. The results were somewhat confusing. researchers had studied the geodetic marks made in these places by the road builders. At first, they thought someone had made a mistake in their measurements, because the discrepancies with the current measurements were from 4 to 60 meters. But the repeated examination confirmed the correctness of the measurements made at that time. That is, from 1923 to 1977, the level of the caldera has risen by 60 meters. But that was not all. 10 years of further research yielded even more unexpected results. During the period from 1990 to 2005, the ground level at this place has fallen, and this indicates a dynamic character of the processes occurring in the caldera. It appears that the volcano was still pretty active. That is, it is far from being an extinct volcano, as first thought. Nevertheless, for complete certainty, it was necessary to have other data from alternative fields which could be cross-checked. The answers came from people who had lived in these places centuries ago. Native Americans lived on the shores of this lake as far back as 11,000 years ago, hunting bison. Remains of their ancient settlements and tools have remained on the shore. Archaeologists collected flint arrowheads and mapped their locations. It turned out that the location of the shore settlements over the past 11,000 years has moved away from the edge of the lake 6 times due to changes in water levels. That is, the rise and fall of the caldera level. It finally became clear that the supervolcano is breathing. And this means that it is almost certainly a time bomb of unimaginable power. And if it erupts, it will be the worst catastrophe in the history of mankind. But how powerful can an eruption be? In order to understand and comprehend the entire power of Yellowstone's explosive potential, we will make some illustrative comparisons, because it would be difficult to grasp the scale of a possible cataclysm in sheer numbers. Volcanic activity indices resemble the Richter scale for earthquakes. From 0 to 1 are small eruptions, with no more than 100 cubic meters of ash thrown into the atmosphere. Level 2 eruptions are more powerful, such as the explosion of Mount Etna in Sicily. Eruption of the Tarawera volcano in New Zealand falls into Level 3. Although the figure seems small, this monster threw out enough ash and slag in 1886 to completely fill 58 stadiums. The even more devastating eruption of Krakatoa volcano in Indonesia in 1883 refers to the 6th level. In short, each level on this scale represents an eruption 10 times more powerful than that of the previous level. It is not difficult to calculate further. If the eruption of Mount St. Helens was the 5th level, then the Yellowstone supervolcano would be at least 1,000 times more powerful at worst. To imagine the power of such an explosion, one needs simply compare it to the largest man-made explosions that mankind conducted with surprising enthusiasm and on an incredibly regular basis until quite recently. Here is the most powerful bomb ever detonated in the US. The Castle Bravo hydrogen bomb, dropped on Bikini Atoll in 1954. Its power was 15 megatons. That's 1,000 times the power of the Hiroshima bomb. Let's move on. The recently mentioned eruption of Mount St. Helens was equal in power to 1,600 Hiroshimas. The volcano threw out over 2.5 cubic kilometers, 0.6 cubic miles of slag, enough to cover all of Manhattan with a 42-meter layer. Now, the eruption generated by the Yellowstone caldera about 600,000 years ago was 1,000 times more powerful than the eruption of Mount St. Helens. According to various estimates, the supervolcano then erupted an average of about 1,000 cubic kilometers of substance. Realize how much greater that is than the 2.5 cubic kilometers in the case of Mount St. Helens. If we continue comparing it to Manhattan and throw out all that volume on 59 square kilometers of the island, then even the highest skyscrapers would be deeply buried under a layer of ash and sludge. It is not certain at all that the supervolcano still contains the same power, But if it does, and if it erupts, one doesn't even want to think about the consequences. But we will do it nevertheless. 1 month before the eruption. Long before the disaster, it was clear to researchers that an eruption was imminent. Weeks or even months before the X hour, the evacuation of people from the Yellowstone region begins. Activists are even trying to evacuate animals. The region in a radius of hundreds of kilometers around the volcano is declared a disaster zone. 1 week before the eruption. Before an eruption, all volcanoes become active. Seismographs will notice it long before the eruption, but there will also be quite visible, obvious displays. The first signs of the coming disaster will be clearly conveyed by the Earth's surface itself. A week before the eruption, or even earlier, there is a creepy phenomenon occurring in Yellowstone. The ground is gradually rising, looking like an inflated balloon that is about to burst. This happens because the magma rushes to the surface under tremendous pressure, destroying the overlying layer of hard rock. Something like this has happened before. Before Mount St. Helens erupted, the ground rose by an average of 1.5 meters. But in Yellowstone, everything happens like under a magnifying glass. More powerful, more massive, and more terrifying. The ground in these areas rises by an average of 3 meters, and it is, putting it mildly, a massive uplift. Hundreds, even thousands of square kilometers. The rise is irregular. The landscape changes before your eyes. Hills appear literally out of nowhere instead of plains, and in some places, on the contrary, the ground subsides, thus forming new valleys. Cameras broadcast the surreal picture live to a horror-struck world. Meanwhile, geologists are trying to find in advance new signs of the imminent eruption, and they are not long in coming. Earthquakes of small magnitude begin. They indicate the passage of magma through layers of solid rock and its movement upwards. These earthquakes are recorded with a special shape of curves on the measuring equipment. Each peak on the curve means that magma has destroyed another massive layer of solid rock. Here is another natural barrier destroyed. And the next one. And the next one. 1 day before the eruption. A sense of anxiety hung in the air. The usually tranquil landscape around the caldera is filled with an eerie, almost physically perceptive threat, as if even nature itself held its breath in horror of the impending cataclysm. There are no more tourists here. All the people have been evacuated. The higher animals are fleeing. They do not understand they are doomed anyway, as they won't have time to get far away enough. But they are driven by instinct. And this is the real mass exodus. Predators and herbivores, forgetting their place in the food chain, escape together. They have nothing left to share. 1 hour before the eruption. The seismograph curves begin to draw elongated zigzags in the form of continuous straight lines, reflecting the rock's vibration. This means that magma has overcome the zone of hard rock and begins ascending at increasing speed to the Earth's surface through hidden cracks and fractures in the Earth's crust. A totally infernal noise starts sounding, similar to the one sometimes made by water in water pipes, but only on a nearly planetary scale. This noise resembles the low tones of an organ, richly laced with infrasound. Ain't it the crack of doom of the 4 horsemen of the apocalypse? And this is not a fantasy. This phenomenon even has a scientific name: harmonic tremor. The connection between such a thunderous effect and the inevitable eruption was first noticed by Bernard Chouet, a volcanologist working for the U.S. Geological Survey. And this sound is the last warning to mankind. 10 minutes before the eruption. The sound grows into a roar, It comes from virtually everywhere because the planet itself is making it. The Earth shakes from the violent shocks. The rocks crumble and huge cracks form. Yellowstone's geysers spew scalding water like mad to heights never seen before, as if trying desperately to relieve the pressure of the supervolcano. But of course, all in vain. The air fills with an acrid odor. It is poisonous sulfuric gases leaking out through the cracks from the depths. Explosion. Although the previous roar of the Earth is literally mind-blowing, it is still nothing compared to the moment of eruption. A brief pause, though only for a moment. For a few seconds, nothing happened. And then, the whole sky flashed blindingly. All the monstrous energy accumulated by the supervolcano for almost 700,000 years had finally burst forth. In an instant, a blinding flash lights up the sky, followed by an impressive roar. It's not even a blast wave, but something much greater. The planet literally cracked, and torrents of molten rock, ash, and superheated gases poured through the wound on its body under tremendous pressure. The deafening roar does not stop. The entire globe rang like 1,000 bells after the impact. The heat scorches forests, vaporizes rivers, waterfalls, lakes. A gigantic mushroom cloud rises many tens of kilometers into the sky, obscuring the sun and engulfing the North American continent in the abyss of darkness. The sky becomes a stormy canvas of swirling ash in which the remnants of sunlight quickly disappear. The blast wave brings a hurricane of volcanic debris that rains down on the surrounding regions, destroying everything. The once vibrant landscape of Yellowstone becomes a desolate wasteland, scarred by the wrath of a raging supervolcano. If hell exists, it is here now. But despite the power, the giant volcano's explosion itself is nothing compared to what will follow. A gigantic cloud of superheated volcanic gases mixed with volcanic ash, dust, and small debris will rush out of Yellowstone in all directions. This phenomenon is called pyroclastic flow, and it is as powerful as it is mysterious. It is these pyroclastic flows that constitute the worst of all the consequences of a volcanic eruption. They sweep across the Earth's surface at breakneck speed, destroying anything remaining in their path after the blast wave. And they leave behind a mere lunar landscape. And it's not just some ash avalanche. Hot streams of rocks ejected by volcanoes can accelerate up to many hundreds of kilometers per hour due to the emergence of a hot air cushion. They can overcome water obstacles and even move uphill. They seem to cheat ordinary friction and move as if they were composed of boiling water instead of ash, rocks, and lava. These properties of pyroclastic flows are still a mystery, and when Yellowstone erupts, they will manifest themselves in a particularly devastating way. Inside such a cloud, the temperature will exceed 800 degrees Celsius. Spreading in all directions, it destroys everything in its path, and there is no way to hide from it. Death in such a scorching cloud comes very quickly, not only because of skin burns, but because of the hot gases getting into the lungs. In an instant after this, all the water in the human body boils at once, and the brain literally explodes from overheating. Scientists have found such gruesome evidence before when they examined the remains of human skulls found at the sites of previous eruptions. For example, the island of Montserrat in the Caribbean Sea provides eloquent evidence of the terrible effects of the pyroclastic scorching cloud. All hell broke loose in this earthly paradise in 1997. when a torrent of superheated volcanic gases descended from the volcano. Witnesses of those terrible events still shudder at the memories of that fateful day when the volcanic gases mixed with ash rushed down the slope at 100 to 150 kilometers per hour and then collapsed into the ocean, continuing to move even on its surface. The power of this cloud was truly terrifying, but its fearsome appearance is nothing compared to what Yellowstone would throw up. To imagine what would happen to a major city if it were in the path of a pyroclastic cloud, it is enough to look at the remains of Plymouth, the capital of the island of Montserrat. It used to be home to 4,000 people. Today, it is already a ghost town. The entire center of the city is covered with volcanic ash. This city is the modern Pompeii. Despite the monstrous consequences of the catastrophe, this eruption was relatively modest in size, and the island managed to overcome its impacts. Although half of the island became unsuitable for living there for a long time. If the supervolcano had erupted, there would have been nothing left alive here within an hour of the eruption. What would happen around Yellowstone during the big eruption? Within an hour after the eruption in Yellowstone, the pyroclastic cloud would reach Jackson Hole Valley, 80 kilometers from the volcano. In just a few more minutes, 90% of the remaining population within a 100-kilometer radius of the eruption site would be dead. Some would die from the explosion itself. Others would suffocate in a cloud of asphyxiating gases. And that's just the beginning. After the eruption, the winds would blow huge clouds of volcanic ash across the United States. What happens after all these masses of volcanic ash fall to the ground? Volcanic ash can rise up to 25 kilometers into the atmosphere and cover half of the United States. 3 days after the eruption, the sky would darken and the air would become dangerous to breathe. Over the 3 days of ash falling from the atmosphere, the situation is predicted to be roughly as follows. Volcanic ash is 6 times the weight of snow, and the roofs of houses are meant to withstand the snow, not something 6 times heavier. This would lead to massive roof collapses. Microscopic particles in the air would clog the air filters of car engines. All flights, without exception, would be at risk because of the danger of ash clogging the engines of airplanes. In the ash clouds surrounding the volcano, although already cooled, there would be strong lightning discharges that would cause forest fires. This has happened before. For example, during the eruption of Mount St. Helens. The worst situation would develop as winds arose in an area stretching 800 kilometers from Yellowstone to Salt Lake City and Denver. Given the nature of the prevailing winds in these areas, the volcanic ash clouds would reach Denver in about 24 hours. In just 2 days, the ash layer in this area would exceed 1 meter in thickness. Traffic would be impossible, and drivers would not be able to see the road. Transportation would be suspended. The wind would pick up clouds of dust from the ground, and all the people in the area would die of suffocation. Dried volcanic ash accumulating on the wires would cause them to break. If the disaster happens in winter, the death toll would be even higher due to hypothermia. The rains would wash volcanic ash into the rivers, polluting them and causing mudslides that would sweep away everything in their path. Pumping stations on reservoirs would become clogged with ash. Many people would be left without drinking water. Nuclear power plants, whose cooling systems depend on inflow of water from the rivers, would also be stopped. Crime would begin to run rampant. Livestock would die from lack of water and food. Hospitals would begin to close one after another. Total chaos would break out. In this situation, children, the elderly, and people with health problems will be the most vulnerable. Up to 500,000 people in the zone affected by the disaster would die just 7 days after the eruption. But it wouldn't be over even after those 7 days. Yellowstone would still be throwing columns of ash into the air. It would already fall 1,500 miles from the eruption site in cities like Santa Fe and Kansas City. And this ash would continue to kill people. This is not quite ordinary ash, as it may seem. It is mineral rock crushed into tiny dust. Associations with moon soil come to mind again, and these are similarities indeed. To see how dangerous such suspended matter in the air is, it is enough to look at volcanic ash through an electron microscope. You can see that these particles have sharp edges and would inevitably destroy living tissue if they get into the lungs. But it is not the physical damage to the lungs caused by this prickly ash that would result in mass deaths, but something much more horrible. Professor Michael Voorhees from the University of Nebraska, a leading American paleontologist, recounted a shocking discovery he made in the 1970s. During one of his studies of relic fossils, his colleagues and he found a layer of volcanic ash, and underneath the ash was the skull of an ancient rhinoceros calf. This was the beginning of a series of incredible finds. The next 3 meters of volcanic rock were literally loaded with skeletons of ancient horses, camels, and rhinoceroses. About 200 animal remains were found, all of which died at practically the same time. Scientists were sure that it was the ash responsible for their deaths, but there was no proof. A chemical analysis of the ash composition revealed that it had been thrown by a now extinct volcano in Idaho. The discovery raised the question, how could volcanic ash kill the animals? The ash is so light that the wind could carry it from the eruption site to Nebraska in just 6 to 7 hours. Only the tiniest particles of volcanic ash can fly great distances. They are so small that we wouldn't even feel them if inhaled. But they certainly pose a hidden danger, a point Professor Voorhees' group was horrified to see when they examined the remains of the dead animals more closely. It turned out that their bones were covered with a strange whitish substance. It wasn't some sort of strange plaque. It was actually bone tissue, but superfluous. It's a classic sign of a lethal lung disease known as Pierre-Marie Bamberger syndrome. When the lungs are disordered, there is a dysfunction in the development of the body's bone system, leading to bone overgrowth. Affected animals died a slow and painful death. Because of the constant pain in their joints, the animals had to stay close to the watering place, where they died one by one. If Yellowstone exploded, no one within at least 1,500 kilometers could consider themselves safe because of the danger of having such a terrible disease. But for those who survived the explosion and the precipitation of ash from the atmosphere, the situation would be even worse. Obviously, the eruption in Yellowstone would cause real devastation throughout the United States. On the first day of the eruption, the population would face the aforementioned clouds of pyroclastic gases, which would destroy all flesh within a radius of 100 kilometers from the place of the disaster. Another 3 days after the eruption, life within a radius of 800 kilometers from the volcano would be paralyzed. The central part of the United States would be covered with a thick layer of volcanic ash, afflicting people and animals with lung diseases. However, scientists are sure that the catastrophic effects would be felt even a few months after the eruption. They believe that the main threat to life on the planet would not even be the ash released into the atmosphere, but the gases thrown into the air by the volcano. You probably have heard about such a weird and scary experience in the history of mankind called the Year Without Summer. It was 1816 when North America and Europe were plunged into unprecedented cold weather. In the United States, That year was even nicknamed 1800 and froze to death. One of the iconic pieces of evidence of those events is in this tombstone, a memorial to a heroic man named Reuben Witten. That year was truly terrible in these regions. It snowed all June, and there were frosts in July and August. It ruined the entire harvest. However, Reuben Witten managed to grow enough wheat by crossing the mountains. In doing so, he saved the town of Ashland, New Hampshire from starvation. But what caused such cold weather, and why did it last only 1 year? There is no doubt now that the cause of such changes on a planetary scale was a volcano's eruption. But it happened 16,000 kilometers away, at the other end of the Earth, in the east of the island of Java. Mount Tambora did produce a powerful eruption, but how could it affect territories on the other side of the planet? And yet, that much. In fact, this is the best evidence of what would happen in the long term when a giant volcano erupts. Tons of sulfur dioxide and carbon monoxide would be released into the atmosphere. They would lead to the formation of special clouds in the stratosphere. These hundreds of tons of sulfur dioxide, combined with atmospheric moisture, create small acidic droplets that are carried by the wind over the entire territory of our planet. They would also act as a barrier to sunlight. As a result, less sunlight would reach the ground, and its surface would begin to cool. It was this atmospheric phenomenon that caused poor harvest in 1816. According to some estimates, the eruption of Mount Tambora resulted in the death of 71,000 people, twice as many as the eruption of Krakatoa volcano. But the long-term effect of a supervolcano eruption would be much, much worse. According to various estimates, the temperature drop on the planet would be at least 20 degrees. That's absolutely catastrophic. It would cause frost and snowfall even in equatorial regions. The heat-loving tropical vegetation would be completely destroyed. In such a scenario, catastrophic climatic impacts on the entire agricultural sector can be expected for a period of up to 2 years. The immediate consequence would be the death of several billion people. And this has already happened. Some scientists believe that the last time something similar happened in the history of mankind was 74,000 years ago. It was also the result of eruption of the giant volcano on the island of Toba in Indonesia. It was a very powerful eruption, roughly equal in magnitude to the one that might occur in Yellowstone. It almost caused the complete extinction of mankind at an early stage of its development. Before that giant explosion, tribes of ancient people had been evenly distributed throughout Africa. After the eruption, however, their numbers declined sharply. The total number of people at that time on our planet was no more than a few thousand. Imagine what would have happened in those years if there had originally been fewer people on the planet, by exactly the same few thousand. Mankind literally squeezed itself into the bottleneck of destiny with great effort, and it may happen again. The only question is, when? To be as objective as possible, we have to admit that this is, after all, the worst development of the worst-case scenario. In reality, however, things may not turn out so badly. Let's see what other volcanologists and the YVO, Yellowstone Volcano Observatory, the most important organization in the field, think. Such a large caldera-forming eruption is of course the most unpleasant scenario. But it may not happen exactly like this, full-on, with such monstrous consequences. Scientists at YVO are now slightly relieved by the fact that each successive eruption of this kind has been weaker than the previous one. Yellowstone, although active, is gradually cooling down. This is clearly demonstrated by the size of the old calderas, the remains of which can be seen in the park. perhaps the volcano changes its mind about erupting, wasting all its energy on geyser shows. According to YVO's least optimistic model, at first, things in Yellowstone would happen as we described earlier in the video. The ground would start to swell up, caused by the rising of the magmatic rock body to the surface, and then a 10-kilometer column would really erupt above it. But it won't be made up of lava, as the movies have scared us, but of the volcanic ash. About 1,000 cubic kilometers of this substance would be released. The ingress of so much foreign matter into the upper layers of the atmosphere would indeed lead to some climatic changes. There is also a model that suggests that the coneless Yellowstone would release most of the ash into the lower atmosphere rather than the upper atmosphere. This would reduce the effects on a planetary scale, but would greatly increase the danger to those in nearby areas. For the first few days, the dangers would be the same. People would be at risk of death by suffocation. Fortunately, there are no major settlements in or near the national park. Since YVO experts promise a forecast at least several weeks in advance, it would be possible to halt tourist access and evacuate the few inhabitants, as well as tourist infrastructure staff. As you can see, the passion for beauty and nature that once led the American community to create such an extensive nature preserve in this area can bring a lot of practical benefits. But what's next? Would there be a volcanic winter and all the horrors that would plague the US and the planet in the worst-case scenario? Probably only in part, and not on such a scale. The ash will begin to settle down pretty quickly. The assumption that it would cover most of America is generally true. After all, traces of ash from the last eruption are found even in California. But the details are important at this point. Within the national park, the ash layer might be as high as 30 centimeters, but 3,000 kilometers away from the volcano, it would be less than a millimeter thick. The consequence could be several poor harvest years. This, of course, is very troublesome, but it would hardly be a fatal circumstance, even for the American economy, let alone for mankind. Although the biosphere as a whole would have to process the consequences within 1 to 2 decades, disturbances in individual ecosystems would probably make themselves felt. The most terrible threat is the possibility of the previously mentioned pyroclastic flow during the eruption, which is capable of overcoming water obstacles and developing a breakneck speed of hundreds of kilometers per hour. With the current level of technology, there is no way to resist it. Although it is definitely the end for anyone who gets in its way, it is by no means the end of the world. Pyroclastic flow has a narrow direction and limited energy resource. Fortunately, the probability of its emergence in Yellowstone is even lower than the probability of a caldera forming eruption. A flow cannot be formed without an eruption, but an eruption may happen without a flow. What about the whole planet? Outside the continent of North America, the average number of cloudy and cold days would increase slightly in the years following the eruption. This could affect individual crops. At worst, prolonged rains, and as a consequence, catastrophic flooding in some areas may occur. Exacerbations of some diseases, such as asthmatic disorders, are likely. This could result in many personal tragedies, but it certainly does not threaten the existence of human beings as a species. The next most likely scenario is the danger of lava eruption. At first glance, it might seem to be about the same thing, but it is not. The worst-case scenario is specifically a supervolcano eruption. Here, instead, we are talking about a much milder way to blow off steam to this ferocious monster. Lava flows happen in Yellowstone much more often than caldera-forming eruptions. Since the formation of the last caldera 640,000 years ago, lava flows have apparently occurred at least a dozen times. The last one happened about 70,000 years ago. Such an eruption is not the most devastating of all possible eruptions, But if it happens again, no one in these lands would be happy. In the best case, the lava would fill the lake, destroying it completely. In the worst case, it would start pouring out of the lake. Fortunately, lava is a rather viscous substance. The average speed is about 100 meters per day, but the advance is unstoppable. During Yellowstone's largest lava outburst, molten rock covered an area of 304 square kilometers. That is, the outflow should not even go beyond the boundaries of the national park. So in case of an emergency, this sparsely populated area would not be too difficult to evacuate, and it is unlikely that anyone would die directly in the lava flow. But alas, there remains the threat of wildfires, which would be much more difficult to cope with. Whatever the scenario, the main question on everyone's mind is, when? When will it all happen? Will we experience these events in our lifetime? On this question, there is also no complete clarity and no consensus. As a reminder, Yellowstone's supervolcano last erupted 70,000 years ago, and it was an extensive magma ejection, not a catastrophic explosion. Let's go back to the beginning of the movie for a moment and recall the concern ordinary people have about the increasing number of volcanic eruptions in the world. Allegedly, it would lead to the eruption of Yellowstone. Well, in the entire time since the last eruption, according to a simple calculation, there have been about 7,000 earthquakes with a magnitude greater than 7 points. None of them have caused the eruption. Neither did the caldera explode in 1992 when the Landers earthquake in Southern California struck, nor did it explode in 1999 when the Hector mine earthquake hit in the same region. Moreover, the earthquake shocks did not cause other volcanoes to erupt, including Long Valley supervolcano in California, which was much closer to the epicenter of seismic activity than Yellowstone now is. That is, it is safe to say that the proximity of the epicenters of earthquakes to Yellowstone does not matter. In 1959, the Hebgen Lake earthquake occurred right on the border of Idaho and Montana, near the western edge of Yellowstone National Park. The supervolcano did not wake up then either. Scientists have to make assumptions based on utterly secondary and indirect data. And it mostly comes down to the detection of signs that would allow us to make predictions only for the short term, not for years or decades. For these purposes, the latest technology has been deployed. At present, dozens of seismographs are installed in the area of the national park. The situation is being monitored by experts from Utah State University, YVO, and other organizations. The key to maintaining predictions about a possible Yellowstone eruption is to carefully study the composition states of the magma. The magma chamber has three main components: gas bubbles, solid magma particles, and liquid molten magma. Just before an eruption begins, the main part of the magma should transform into liquid form. Presumably, this requires the transition to liquid form of 50% of the magma substance. But what volume of magma under Yellowstone is already in liquid form? To find the answer to this question, scientists had to analyze seismic waves from earthquakes. Using ultrasound scanning, they assessed the formation state, and according to the findings at the time, only 10% of the magma around the caldera was in a molten state. But many years had passed since those studies. Already in 2003, geologists noted clear signs of a sharp increase in volcanic activity. In addition, typical cracks were found on the surface of the ground in some areas of the national park. The only thing that could cause such a sharp rise in the ground level is a change in the magma state. Back then, scientists quite seriously assumed it was evidence of a possible approaching eruption. But again, many years have passed and nothing has happened. So far, no one is sure what this will bring in the future or how distant this future will be. Uncertainty and vagueness of predictions resemble predictions of an explosion of the star Betelgeuse. No matter how many times it has been buried by journalists, the forecast is the same. It may happen tomorrow. It may happen in 100,000 years. Anyway, we do not want any scenario of eruption, neither bad nor good one, because the consequences would be very severe in either case. But is there any choice in this case? At first glance, there doesn't seem to be any. It's difficult to even imagine that we can restrain such a thing as a supervolcano. But no one forbids scientists to at least think in this area, right? In 2017, Brian Wilcox, a member of NASA's Planetary Defense Advisory Council, who has been doing research on the threats of asteroids and comets, announced some pretty fantastic plans of NASA. To counteract the deadly threat to humanity, NASA allegedly plans to drill holes in the lower parts of the volcano's caldera outside Yellowstone National Park. The project organizers then plan to pump cold water at high pressure into the supervolcano and then pump it out. The inflowing water will cool the magma, and the outgoing water, which is estimated to be heated to about 350 degrees Celsius, can be used to generate electricity. Yellowstone currently generates about 6 gigawatts of heat, Wilcox said in an interview. By drilling and heating the water this way, it could be used to create a geothermal power plant that generates electricity at extremely competitive prices of about 10 cents per kilowatt hour. That's how the space agency addressed the possibility of artificially cooling the volcano by 35% so that it would no longer pose a threat. Sounds epic, to put it mildly, and not entirely plausible. In the interview, though, Wilcox did note that the plan is only theoretical so far, because there is no data on the risks of drilling the volcano's caldera. Let's be honest, as of today, there is not a single method, much less a realistic one, to eliminate the threat from Yellowstone. But the threat itself is quite probably highly overstated as well. According to YVO staff, the most pressing threat in Yellowstone today is earthquakes and hydrothermal explosions caused by the accumulation of superheated water vapor beneath the surface. Even a slight increase in volcanic activity can lead to dangerous situations: fractures, changes in water flows, avalanches, rock falls, rapid evaporation of reservoirs, and the release of poisonous gases to the surface. Try to imagine what could happen to a tourist group in a narrow mountain canyon in such a case. It is for these reasons that volcanologists demanded a temporary suspension of tourist access to the park in 2003. Apparently, this event was the starting point for the panic rumors. But recorded volcanic activity at the time only slightly exceeded the background. The danger of a new eruption was out of the question. Then, for several years, tourism visits to Yellowstone proceeded as usual. Geysers behaved decently and spit boiling water no further than their established customary range. Nevertheless, researchers continue to monitor the behavior of Yellowstone's attractions carefully to raise the alarm in time. And we can only hope that this alarm will be of a local scale.